We're going to talk here about finding horizontal asymptotes of rational functions. So horizontal asymptotes all are what's happening when x is going to positive infinity or negative infinity. And so what's going to matter here is actually the degree of the numerator and the degree of the denominator. So we say take our rational function, which can be written as a quotient of two polynomials, p and q. And we compare the degrees of these two polynomials. Remember, the degree of a polynomial is the highest exponent on x. We compare the two degrees, and we've got these three different cases. Okay, if the degree of p, the numerator, is smaller than the degree of the denominator, then y equals 0 is a horizontal asymptote of your function. If the degree of the numerator is larger than the degree of the denominator, then we actually don't have any horizontal asymptote. And third, if the degrees are equal, so for example, you have a quadratic in the numerator and a quadratic in the denominator, then the vertical asymptote is the quotient of the leading coefficients of the numerator and denominator. Now, what's going on here is actually very straightforward to understand. So let's talk about that real quick. I'm just going to give you three examples. So we'll start with an x plus 1 over x squared minus 4x plus 2. And we will look at an x squared plus 5x minus 3 over 2x minus 1. And 3x squared plus 5x minus 9 over 2x squared plus 4. All right, so let's talk about why we care about the degree. Remember, a horizontal asymptote is what our function is approaching as x is approaching infinity or negative infinity. Now, as x is approaching infinity or negative infinity, that means that we really only care about the highest power of x because that's kind of the term that takes over as x gets large. So looking over here, in our denominator, okay, the x squared grows extremely fast. Okay, think about if x is 100, all right, then 100 squared is 10,000, okay, and then minus 400. Well, that's not very, 400 is pretty small compared to 10,000. And of course, the plus 2 is pretty much nothing. And so the highest power of x is the one that really kind of takes over. Now, 100 isn't even that big of a number. Remember, x is going to infinity. So we look at the highest power of x, and that term is what takes over. So here we have this x squared on bottom, that's the controlling term down there. And in the numerator, we have just x. That's the highest power of x that we see in the numerator. So what we say is that as x is going to infinity or negative infinity, this function behaves more and more similarly to x over x squared, which is 1 over x. Okay? Now, if the degree of the denominator is bigger, that essentially means that our denominator grows so much faster than the numerator that, that this fraction approaches 0. Okay? And that's where this first case comes from, is that our degree in the numerator is smaller, so the denominator grows so much faster that the fraction as a whole gets closer and closer to 0. And so that's how we get our horizontal asymptote of y equals 0. For the second case, if the degree of the numerator is larger, as we have right here, okay, x squared in the numerator grows so much faster than 2x in the denominator that as x goes off to infinity, our numerator kind of takes over, and it grows and grows and grows and grows, which means we're not going to approach any one value. Okay, and that is what tells us that there is no horizontal asymptote. And finally, in our third case, if the degrees are equal, as we see here, okay, they both have degree 2, these x squared and x squared, of course, grow at the same rate. It's the 3 and the 2 that will kind of affect things, okay? And so that's where we get the leading coefficients. So the horizontal asymptote of this third one would be y equals 3 over 2. Because the other terms are pretty negligible as x goes off to infinity, but the 3x squared over 2x squared would reduce to 3/2.